So now that we know how to implement it, as we usually do, what my style is, now let's look at the math. Because in math, what happens is to kind of compress everything into this one equation. It looks a little bit difficult. It looks a little bit, complicated. But even before we do that, I'm going to show you something really cool. And what that is, like Christie's. I don't know if you know, but Christie's is essentially an auction house, right? They auction really expensive things, paintings of Van Gogh and Leonardo da Vinci. And these guys, they kind of created this art in about 2018, right? And here they were able to kind of sell it for a lot of money. I think about $500,000. Yeah, about $432,000. And they were the ones who kind of showed this equation, probably the only equation on their website. So I found that really interesting, because GANs were like such a hype that people were even, able to sell it as. And so if you look at the website has nothing to do with machine learning. This is just a direct, let's say, auction website for high-end art objects, and you're welcome to check it out, right? So now let's go back to what these Christie people are doing and what this equation actually looks like. By the way, here what the website says is it's the portrait in its gilt frame depicts a portly gentleman, probably French, and to judge his dark fur coat and plain white collar, a man of the church, etc. So I think a story is really so powerful, because this is essentially an image from a generator which has not trained well, right? We don't like this image, but you can still spin a beautiful story around it and probably call it art. So now, how we train the generator is, we have to maximize the generator when, you're putting in the real images, and it should be minimized when you're putting in the fake images. At the discriminator and at the generator, you have to again maximize the output. So what I mean by here is, we know what is a simple binary cross entropy loss, right? It's simply, so let's say our two outputs are, so if this is y hat, this will be 1 minus y hat, because after softmax, they both sum to 0. We can also call it, I don't know, like k hat. So this can be k hat, but this is essentially 1 minus y hat. And for this reason, what we do is we do y. So we don't know which one is the correct label, but this is the label 1 and this is the label, let's say, 0. So it's essentially whichever is the correct class, you will get a loss from that, right? If you write this thing out. But like I always do, the easiest thing to remember is to take the negative log of the correct class, of the positive class or the negative class, right? So it's just one loss over. But if you want to write this whole thing out, instead of having been able to draw this vector, then you need to write this equation out. But this is nothing. So if y is 1 and if y is 0, then, so if y is 1, then, this term will get activated, and if y is 0, then this term will get activated and this term will be 0. Now, what we want to do is at the discriminator, we are saying that we can have two possible inputs. It can be real or fake. For real, y is equal to 1 in this case, and substituting the entire binary cross entropy loss with y equal to 1, this is what we get, right? So what we're doing is we're substituting y equal to 1 and we get negative log of dx, where dx is the output of the discriminator for a real input image. Similarly, when y is equal to fake, this is what we get. Combining both of them for the discriminator, this is what we get, right? So the goal of the discriminator is to minimize this loss, right? You want to do a min over this whole thing. That's straightforward. And now instead of min, if you want to remove the negative sign, we can also call it max. So we remove the negative sign and then we're saying we're maximizing this at the discriminator. So the discriminator part is done. Now let's look at the generator. Well, the generator, what we are doing is we want to flip the label, right? We want to maximize what we had. So we had so what we want is we want to minimize the log of 1 minus d of g of z, right? So this is essentially our this equation. Yeah, so we want to do this equation but with the flipped clause. And now so if we have this, and then if we want to write both of them together, we want to maximize the discriminator, minimize the generator over this loss function. And in a sense you can also write it as g min d max of log of d of x and then e, so this one. And it's essentially writing this whole thing, the whole business of training the discriminator, training the generator in this one equation. And this is why, because we are compacting everything, it looks a little bit, let's say, difficult at the first go when you look at this equation. But this equation now, whenever you see it anywhere, it should be pretty straightforward.